In this video, we're going to look at the difference between partial and direct variation. So we're going to start off with this example here. Let's pretend that this is a field trip for a bunch of students, and there are 4 different locations that we can go to. And the different locations have different prices associated with them depending on how many students go. So in order to illustrate the difference between partial and direct variation here, what we're going to actually do is we're going to create an equation for each of these 4 relationships. If we have an equation, we'll be able to see the difference between partial and direct variation pretty simply. So this first one here. Well, in order to create an equation from a graph, I think the easiest way is to pick a few points. Okay, I'm just going to pick these points here. I don't like these points in between as much because it's 0.5. It's not as nice. And the reason why we do this, by the way, is because we need to find the rate of change, right? In order to come up with an equation, we need the rate of change of the graph. So that's fine. Those are the 3 points here. So in order to find the rate of change, I'm just going to make a quick table. So the first thing is the students, and then there's the cost, right? So if 0 students go on the trip, it's apparently still going to cost some amount of money, right? And I think that's going to be $5 right there. If 1 student goes on the trip, it looks like it's going to be $15, right? So let's fill that in our table. 0 students is going to cost $5, so there's like an upfront cost. 1 student is going to cost $15. And 2 students, that second dot, is going to cost $25, it looks like, right? So how do we find the rate of change from this? Well, we look at what it goes up by, right? So 5 to 15, we're going to add $10 for 1 student, right? Plus 1 student. And then from 15 to 25, we're adding another $10 for another student. So the rate of change is going to be $10 per 1 student, or just clearly $10 per student, right? Okay. So that's the first part of our equation, right? But we also need the starting point, right? Or the initial value, as we call it. So we see that it starts at 5 here, and it goes up by 10 each time. So how do we write that as an equation? So the cost is going to be, well, we said it starts at $5, and then each student, it adds $10. And mathematically, we write that as plus 10 times the number of students, plus 10n. So there's our equation for this one, right? Okay, pretty straightforward. So this equation can be used if there were 25 students in the class, for example, we can plug in n is 25 and find the total cost, right? Let's do the same thing for relationship B. So we're going to create a quick table here. So again, to find the points, I think these are good points. 0, 2, 4, right? Those are good points to pick. They fall right in the corners. So I'm going to make a very quick table here. So we're going to have students and dollars. So you might notice if there are 0 students that go on this trip, it's going to cost $0. That first red point there is down in the corner, right? If 2 students go on the trip, it's going to cost $20. And if 4 students go on the trip, it's going to cost $40. So we can look here. It's going up by 20, but this is for every 2 students, right? So to find the rate of change, we would do the same thing. We would divide $20 for 2 students is going to give us $10 per student. So you might notice that's the same price per student as the first one. But how can we come up with our equation here? So our equation, remember, might look something like that other equation. But we notice that it starts at 0. So we could do that. We could do starts at 0, and then it adds $10 per student. So 0 plus 10n. I'm going to actually simplify this. If it's a 0 in math, we don't really need to write it, right? So I'm just going to write 10n. Okay, that's good. Let's do these last 2. So these last 2, they give us a table instead. So it's going to be a little bit easier because we don't have to create a table because the table is given to us, right? So this one here, we can check what it goes up by, right? So 10 to 15 is $5. 15 to 20 is $5. And it looks like this pattern continues, right? And on the left side, for the number of students, it just seems to go up by 1 each time. Okay, so that's not a problem. So the rate of change of this relationship is just going to be $5 for every student. Right? We don't really need to divide 5 by 1. We just know it's going to be 5. So what's our equation here? Well, what is the starting value? Right? We always, in our equation, we need to include the starting value as well. Well, if we had 0 students here, how much would it cost? It would still cost $10. So our initial value, our initial value is $10. So even if no students go, it's going to cost $10. So we have to include that in our equation as our initial value. So it's going to start at 10, and then each student, it's going to go up by $5. And the way we write that is 5 times the number of students. So that's our equation there. Okay, not really a problem, right? Let's try to do an equation for this last one now. So here we see that this seems to be, well, first of all, the number of students seems to just be going up by 1 each time, right? So we're just adding 1 student each time, which is good. That makes it nice and easy. The cost seems to be going up by 15 each time. Just want to check, does it work for all of them? Yep, it does. Oops. So that tells us the rate of change is going to be, well, it's just going to be $15 for every 1 student. So $15 per student, right? That's not a surprise. So then we look, what's our starting value for our equation? So when we come up with our equation, we always want to start with the starting value. So the starting value, it looks like here it's, the first value here, clearly, it's got to be 15, right? So we should do 15 plus 15n, right? But we have to be careful. How is this different than the previous table? Well, if you look at the previous table, the previous one is different because it tells you how much it would cost even if 0 students went, right? It would cost $10. But this one doesn't tell you how much 0 students cost. So the thing is, we actually can't just put in the 15 as the initial value because it's not the initial value. The initial value always happens where there's a 0 here. It's the thing that corresponds to 0. Or on the graph, it's the thing where it would be corresponding to 0. So on the left axis, right? Where does it cross that left axis, the initial value? So the trick to this question is we need to figure out what that initial value is. So the way I like to do, I like to just squeeze in a 0 here, right? Squeeze in like another row on your table. And you'll notice the pattern can help us figure this out. We need to go sort of down each time here. We need to go up by 1. So in order to go backwards, we needed to go down by 1, which gets us to 0. And it's going to be the same thing on this side. This side, we needed to go up by 15 to go up the table, or down the table, I should say. So to go backwards, what should we do to get to 0? Well, we got to do the opposite. We got to subtract 15, right? So what's 15 minus 15? 0, right? So if 0 students went on this trip, there's no initial fee, there's no starting cost, so it would still cost $0, right? So the initial value here is actually 0. Don't let that fool you in a question. If it doesn't give you the value at 0, you got to find it yourself by going backwards in the table. So to come up with the equation now, you'll notice that the starting value is 0, so we can put 0, and then it goes up by $15 per student, so plus 15n. Or just C equals 15n. We don't need to write that 0. So we now have our 4 equations that go along with these 4 relationships, right? They all tell us how much it would cost for a certain number of students on each trip. But the question is, do you notice any differences between these 4 relationships? 2 of them are similar and 2 of them are different if you look at the equations. You should notice the 2 on the left have 2 things in the equation. They both have an initial value and a rate of change. An initial value and a rate of change. The ones on the right only have a rate of change, right? The initial value for them is both 0. So this is the difference between partial and direct variation. When we have the initial value is 0, so the graph starts from the corner, right? It starts down at 0, 0. Or the equation doesn't show its rate of change, so that means it's 0. Or the initial value on the table is 0. We call this a direct variation. Okay? If there is an initial value that is not 0, or the graph doesn't start from that corner, we call this a partial variation. Okay? So these two are partial variations, these two are direct variations. And sort of the little sketch that I like to do, partial variations, if you were to graph it, start not at 0. But direct variations always start at 0, right? So the key difference is, again, just to go over it one more time. For partial variation, it doesn't start at 0, so the graph isn't going to start at 0. For a direct variation, it does. For an equation, a partial variation has an initial value. A direct variation does not. It's 0. And lastly, from a table, if you find the initial value, it's going to be something other than 0 in a partial variation, and it's going to be 0 in a direct variation. But you always got to remember, if you're not given the value at 0, you got to find it yourself before you can determine if it's partial or direct. Okay? There you go. So what I recommend you do now, try those 2 problems on the next 2 pages. They'll sort of test your understanding of partial and direct variation.